Hello guys, today I'm going to help you solve the LeetCode problem 2290, minimum obstacle removal to reach corner, which is the daily LeetCode problem for November 28, 2024. So here we're trying to find the minimum path to go from the top left corner to the bottom right with removing the minimum amount of obstacles. And there's a couple different ways to do this. How I'm going to do it though is with a breadth first search, where we maintain the minimum amount of obstacles to pass as we work through it. And you'll see how I go about it now. First off, with most grid problems, I like to just declare M and N. M, the variables M and N up front. Just like that. And in addition, to complete the checks, we're going to need to check the four cardinal directions of up, down, left, and right. And so I'm going to create a little array here to do that. You're going to go right, left, up, and down. So for right, it would be 0, 1. For left, it's going to be 0, -1. For up, it is going to be -1, 0. In fact, yeah. And then for down, it's going to be 1, 0. And I think I'm going to swap these around. It makes more sense because we're traveling down and right. I think it might make more sense to do it that way. Okay, but we have our directions, and now we want to create a visited array. Typical breadth first search, use some kind of visited map or array or set to keep track of what you've visited so far, and we're going to do that here. I'm going to call it minimum obstacles or minimum OBS. We're going to do a little bit of fancy declaration here in Python where we're going to initialize everything to infinity. So it will just be lower, and this way we'll know if it's visited or not. So basically if it equals infinity, we know we haven't visited yet. So we do this times n, and then 4 underscore and range m will create a duplicate grid that maintains this visited count. We also need a q or a dq, and we are going to do two things here. We're going to set the starting grid square, which is the top left. We're going to go ahead and set this equal to 0. And we are going to append it to our dq. And we're going to have 3 variables here, which is going to be the number of obstacles and the current row and column. So this is obstacle count, row, and column. So now we're going to be able to go through this. Only thing we want to create first is we are going to say valid element. This is where we will check if it is a valid row and column within the graph. And so this is very common if we're using these cardinal directions, or we're going to use it to update and check in the 4 directions. You're going to usually need a valid, some kind of way to check that that's within the bounds of the given array. So you can do that by saying this little one-liner. So if 0 is less than or equal to row, which is less than rows, it'll be m. And we have 0, which is less than or equal to columns, which is going to be less than n. Cool. And so with this, we're go ahead and able to start the BFS. We're going to do a couple different checks. So while q, we can do q dot pop left. And with this, we will get the obstacle count. We'll get the row, we'll get the column. And now we're going to check in the 4 different directions. So I'm going to say for R, C in directions. Say new row, new column is going to equal row plus R and column plus C. So now we can go ahead and check. And the first thing we want to do is we want to check if it's valid, and we want to check if it isn't visited yet, by meaning if it's equal to infinity. So here we can do that. So we go if valid element, new row, new column, and we're going to say minimum obstacles, bracket. In fact, I want to shorten these. No, actually that's fine. New row, new column equals float infinity. So now we know this is valid, and we have not visited this yet. So now we're going to do two other checks. We're now going to go and see if the grid, if this is an obstacle or not. So if this is an obstacle, we'll check that here. Okay, so if this is one, we are going to add it to our queue, but we're going to add it to the end of the queue. And we're also going to set the obstacle count for that. Let's set the obstacle count first. So min OBS, new row, new column. Since this itself is an obstacle, we can set this to our current obstacle count plus 1. And now we will append it to our DQ. We can say q dot append. You see here, this is appending to the end of it because we want to visit the free spaces first. So q dot append. We're going to do the same OBS count plus 1, new row, a new column. So now we'll go in the else. If this is an open space, this is good. Here we can say minimum OBS for the new row, new column. We are going to set this equal to the current obstacle count that we've gone through already. We will now q dot append left because we want to search the new spaces first. And so that way up here, we're just appending to the end of the queue. Appending to the left, we're going to put this at the beginning. So OBS count, new row, and then new count. So with this, I think this is all we need. We can just now return minimum obstacles of n minus 1 and n minus 1. Let's give this a run and see if I am missing anything. And it looks like I have a dumb typo on my part. Hopefully that's it. Cool, we're past those tests. We can go ahead and submit and see how our efficiency is on this. And look at that, it's pretty efficient. Okay, thank you guys.